Hey everyone, and welcome back to the channel. Ever wonder how your favorite apps or games seem to think and respond to what you do? Like, how does a game know if you won or lost? Or how does an app show you different things based on your age or location? That amazing decision-making power in code comes from something super important called conditional statements. In this video, you'll learn how to make your Python program smart by using the essential tools, if, elif, and else. By the end, you'll be able to write code that can choose what to do based on different situations. Get ready to add powerful logic to your code. Let's dive in. All right, let's start with the basic idea. Think about making decisions in real life. If it's raining, you take an umbrella. If you're hungry, you eat. If it's sunny, you might go outside. Conditional statements in programming work the same way. They let your code check if something is true or false and then run different blocks of code based on the result. The most basic conditional is the if statement. The structure is simple. You type if, then you give it a condition to check, and then you put a colon. Temperature equals 25. If temperature is greater than 20, print it's warm. Look at this example. We have a variable temperature set to 25. The condition is temperature greater than 20. Since 25 is greater than 20, this condition is true. Now, notice the line print, it's warm, is indented. This is super important in Python. Indentation tells Python which code belongs to the if statement. If the condition is true, Python runs the code that is indented below the if. What if the condition is false? Well, that's where else comes in. The else statement is paired with an if. It says, if the if condition is not true, then do this instead. Temperature equals 18. If temperature is greater than 20, print it's warm. Else, print it's not warm. Here, temperature is 18. Is 18 greater than 20? No, that's false. So the code under the if is skipped, and Python jumps to the else block and runs the code there. Just like with if, the code under else must be indented. Else doesn't need a condition because it runs only when the if condition, or all elif conditions, which we'll see next, is false. But what if you have more than two options, like warm, cold, or just right? For that, we use elif. Elif is short for else if. You can have multiple elif statements between an if and an else. Python checks the if condition first. If it's false, it checks the first elif. If that's false, it checks the next elif, and so on. If all if and elif conditions are false, the else block, if it exists, is executed. Temperature equals 22. If temperature is greater than 25, print it's hot. Elif temperature is greater than 20. This is checked. If the first if is false, print it's warm. Else, this runs if both if and elif are false. Print it's cool. In this case, 22 is not greater than 25, so the first if is false. Then Python checks the elif, is 22 greater than 20? Yes, that's true. So it prints it's warm and skips the else block. Remember, Python stops checking as soon as it finds the first condition that is true. Now, what exactly goes into these conditions? We use comparison operators to compare values. Equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. These operators compare two values and give you back either true or false. This true or false is exactly what the if, elif statements need. X equals 10, y equals 5, print x equals y. Output, false, print x not equals y. Output, true, print x is greater than y. Output, true. You can see how these comparisons result in true or false. Sometimes you need to check more than one thing at the same time. For that, we use logical operators, and true if both conditions are true, or true if at least one condition is true. Not reverses the result, true becomes false, false becomes true. Age equals 25, has ID equals true. If age greater than or equal 18 and has ID, print you can enter the club. If age is less than 18 or not has ID, print you cannot enter the club. In the first if, both age greater than or equal 18, true, and has ID true are true, so true and true is true, and the message is printed. In the second if, age is less than 18 is false, but not has ID, which is not true, so false makes the whole or condition false or false, which is false. Let's change the example slightly. Age equals 16, has ID equals true. If age is greater than or equals 18 and has ID, print you can enter the club, else print you cannot enter the club. Another example with or, is student equals true, is senior equals false. If is student or is senior, print you get a discount. Now age is greater than or equals 18 is false, so the and condition is false and the else runs. In the second example, is student is true, so even though is senior is false, true or false is true, and the message is printed. The not operator just flips the result of a condition. Not true is false, and not false is true. Is logged in equals false. If not is logged in, print please log in. This if condition not is logged in becomes not false, which is true, so the message is printed. Okay, we've covered the theory. If, elif, else, comparison operators, and logical operators. Now let's get our hands dirty with some live coding. All right, let's open up our code editor. We'll start simple and build up. First, let's check if a number is positive or negative. We'll ask the user for input. Check positive, negative. Num star equals input, enter a number. Num equals int num star. Convert input string to an integer. If num is greater than 0, print this is a positive number. Elif num is less than 0, print this is a negative number. Else, print this number is 0. We get input, convert it to a number, then we use if to check if it's greater than 0. If not, elif checks if it's less than 0. If neither is true, it must be 0, so the else block runs. Let's run it. Enter 5. This is a positive number. Great. Enter negative 3. This is a negative number. Perfect. Enter 0. This number is 0. Awesome. It works as expected. Now let's build a simple grading system based on a score. Simple grading system. Score star equals input. Enter the student's score, 0 to 100. Score equals int score star. If score is greater than or equal 90, print grade A. Elif score greater than or equal 80. Checked only if score is not greater than or equal 90. Print grade B. Elif score is greater than or equal 70. Checked only if score is not greater than or equal 90 and not is greater than or equal 80. Print grade C. Elif score is greater than or equal 60, checked only if previous conditions are false. Print grade D. Else, if none of the above conditions are true. Print grade F. See how the elif statements are checked one by one. If the score is 95, the first if score is greater than or equal 90 is true, it prints grade A, and Python skips all the elif and else blocks. If the score is 85, the first if is false, the first elif score is greater than or equal 80 is true, it prints grade B and skips the rest. Let's test it. We see that 92 maps to an A, 85 to a B, 78 to a C, 61 to a D, and 55 to an F. Looks correct. Now, let's look at common errors you might make and how to fix them. If you forget the colon after if, elif, or else, Python will give you a syntax error. See, it says syntax error expected. The fix is simple. Just add the colon. Incorrect indentation. Indentation is crucial. If you don't indent the code block under if, elif, or else, you'll get an indentation error. Python tells you it expected an indented block. Make sure the lines belonging to the conditional block are indented by the same amount, usually 4 spaces. Error 3, using single equals instead of double equals. This is a classic. Single equals is for assigning a value to a variable. Double equals is for checking if two values are equal. Using single equals in an if statement condition like this will likely give you a syntax error or unexpected behavior. Python expects a comparison that results in true or false. Always use double equals when you want to check if two things are the same. Error 4, logic errors with and/or operators. Sometimes the code runs, but it doesn't do what you expect because the logic in your and or condition is wrong. Remember our club entry example? If age greater than or equal to 18 and has ID. If you meant they could enter if they are 18 or they have an ID, using and would be a logic error. You need to think carefully about whether both things need to be true or just one of them. The best way to avoid these is to write out the condition in plain English first and then translate it carefully into code. Also, test your code with different inputs that should hit each part of your if, elif, else structure. Now that we've seen how conditionals work and how to avoid common pitfalls, let's use them to build a little project. We're going to create a simple what to wear program based on the temperature and maybe if it's raining. First, we greet the user. Then we ask for the temperature and convert it to an integer, just like before. Next, we ask if it's raining. We take their input, convert it to lowercase using .lower, and check if it's exactly yes. This comparison is raining star, lower equals yes, will give us true if they typed yes or yes, yes, etc., and false otherwise. We store this true-false value in the isRaining variable. This is a neat trick. Now the conditional logic. We start with the coldest case. If temp is less than 0. If it's below 0, it's freezing. The next elif checks if the temperature is less than 10. If the first if was false, this means the temperature is between 0 and 9 degrees. Inside this elif, we have another if-else. This is called a nested conditional. It means we make another decision inside the first one. If the temperature is between 0 to 9 and it's raining, if is raining, we give one suggestion. Else, if it's not raining, we give another. We repeat this pattern for temperatures less than 20, meaning 10 to 19 degrees. Finally, the else block at the end catches anything that wasn't less than 20, meaning 20 or higher. Again, we check if it's raining inside this else block. Let's run this. Temp -5, not raining, it's freezing. Temp 5, raining. It's cold and wet. Temp 15, not raining. It's cool. A sweater. Temp 25, raining. It's warm but raining. It seems to work. This simple program shows how you can combine if, elif, and else, and even nest them to create more complex logic in your programs. You've done great so far. Now it's time to practice and stretch your skills. Your challenge: write a Python program that asks the user for a year and tells them if it's a leap year. Remember the rules for a leap year. A year is a leap year if it is evenly divisible by 4, except years divisible by 100 are not leap years unless the year is also evenly divisible by 400. You'll need to use the modulo operator to check for even divisibility, e.g., year modulo 4 equals 0, and you'll definitely need an and or in your conditional statements. This little formula should help you structure your main condition. Think about how to put that into an if-else structure. You can find the exact challenge code and input-output examples in the description below, along with starter code to help you get started. For those who want to explore further, how would you handle someone typing in text instead of a number for the year? You might need try and accept blocks, which is a more advanced topic for handling errors. Research Python's match statement, available in Python 3, 10, and later. It's a newer way to handle multiple choices that can sometimes be cleaner than many elif statements. Wow, you've learned a ton about making decisions in your code today. Let's quickly recap. Conditional statements, if, elif, else, allow your programs to choose which code to run based on conditions. Conditions are statements that evaluate to either true or false. We use comparison operators like equals, greater than, less than, etc. to create conditions. We use logical operators and or not to combine or modify conditions. Indentation is critical in Python to define the code blocks under if, elif, and else. You've just unlocked a fundamental way to control your program's flow and make it much more dynamic and useful. Now, making decisions is powerful, but what if you want your program to repeat actions, like do something 10 times or do something until a certain condition is met? That's where loops come in. In our next video, we'll explore for and while loops to make your code perform repetitive tasks effortlessly. Get ready to automate. Before you go, make sure to check the description below. I've included all the code snippets we used, the challenge code, and other downloadable resources like a quick guide to conditionals. There's also a quiz linked that you can take right now to test your understanding. It's automatically assessed and you'll get your results instantly. Plus, you'll find the key takeaways from this lesson there. If you found this video helpful, please give it a like. It really supports the channel. Subscribe if you haven't already, and hit that notification bell so you don't miss the next video on loops and future Python tutorials. Thanks so much for watching. Keep coding, keep practicing, and I'll see you in the next video.